Hello all, welcome to Tech with SAS. In the previous two videos, we have understood two algorithms which are leaky bucket and token bucket. So in this video, we are going to cover three more algorithms which are fixed window, sliding window, and sliding log, right? So these three algorithms we will cover for the rate limiter. So let's start on that. In fixed window algorithm, we define a window to serve requests. For example, we define, okay, we will serve 10 requests per minute, right? So for every minute, we are going to serve just a 10 requests. So for example, if we have a fixed window of 1 minute, right? And which is starting at suppose 0 0 0 0 second. I mean, yeah, 0 seconds, right? So, and then uh, when it is like 0 0 0 0 5 9, right? So for this 1 minute, we are going to serve the 10 request. So for example, if any request is coming at suppose 0 0 0 1 second, right? So we are going to serve it, right? Then again, suppose some seconds have passed, and now till 20 seconds for in this window, we have served the 8 request. Still, we are good because our SLA is within the limit. Now at 0 0 35 second, we have served the 10 requests for this window. But now what happens that if any request coming after 35, right, it will be discarded because we have already served the 10 requests for this fixed window, right? So that is called the fixed window algorithm. And here we will basically serve the request in that window. If that window is already not elapsed, but request has been served, we will discard the incoming requests which are coming in that window. Okay. So this is called a fixed window algorithm. Here is like one problem. For example, if you have like suppose two consecutive windows, right? Like suppose you have a window one, which is and window two, and window one is basically is starting from 0 0 seconds and going to 0 0 5 9 sorry 5 9 seconds. 1 second. Yeah, so it is going to 0 0 5 9 second, and second window start after the 1 minute, and it goes to the 1 minute and 59 seconds, right? So now in this particular case, what happens that for user one, requests have not come till suppose 0 0 50 seconds. And now there's a burst of request at 0 0 50 seconds, right? And suppose 10 requests have come and you have served because in this particular window you are going to serve the 10 requests. So now you have served the 10 requests, but this burst of requests is still continuing, and till start of next window until suppose 0 5 second, right? Again you have served the 10 requests, no? Now what happens that in the span of just 15 seconds you have served the 20 requests, right? But what we wanted basically to distribute the load over the whole window. But now in this case, what happened that there is overloading on the server because a server is super busy between the 0050 to this 10150, right? So basically, in 15 seconds, we are serving more requests, and for other, I mean, server is idle, right? So this is the fall of this fixed window. Okay. To overcome the issues which we have seen in the fixed window algorithm, we use the sliding loss algorithm. So in this, what we do, we create a log, right? So log can be in a form of a hash set or maybe a Redis or some other table. Or so basically, you create a log, right? And for every request, suppose you have request coming like this, So all those requests you are storing in this log, right? So now, for example, there is a SLA of 10 requests per minute, right? So for now at this time, suppose that now time is the 11 30 and 00, right? So what happens that we see uh, the previous 1 minute, and also when we store this request, right, we also store the timestamp with. So at what time this request was recorded or arrived, right? So we know, okay, for every request we have a timestamp, right? So then what happens that for the previous 1 minute, for example, now the time is 11:31, right? So for the previous window, how many requests we have served? Uh, so I mean, how many requests we see in the logs, right? Suppose we see that, okay, there are 8 requests, right? So okay, so it means that we have the room for 2 more requests to be served, right? So now we'll serve them. But suppose in the next window, we see that there are 25 requests lying on the logs to be processed. But but what we do, we just go beyond the 1 minute from the current time and see, okay, now the requests are lying as say 12 requests, right? So because the request, the time is the limit, right, which we have set as a 10 requests per minute, we already have served 12 requests already, right? So we will not serve any more requests. So what happens in this algorithm, we store the request as a log in a log file, or maybe in a hash table mostly, and then for every last 1 minute, right, we check that how many requests have arrived or pending to be processed. And if requests are like more than the SLA, I will discard them. So this is how this algorithm works. But now the major problem which we see in this algorithm, that because what is happening, that we are storing each request and timestamp into a log file, right? So if there's some system which is like is used by the billions of users, so are you going to store those billions of requests here? It's a problem, right? So that's why it's a memory problem, because you have to have the huge memory to implement this algorithm. So now we have seen the fixed window algorithm and the sliding logs algorithm. So both have some inherent problems, such as the sliding logs is storing the huge amount of data, which is very memory inefficient. And for the fixed window, we are not getting the proper smoothing of traffic, right? Because there might be some outburst at the fag end of the window. Okay, so to overcome those challenges, we have one more algorithm called the sliding window counter. So in this, what happens that we same thing or here also, we use the logs, right? We use a log where we store all the requests which are coming from the client, right? So what happens that here we don't save all requests separately. What we do, we combine request and then save. For example, we have one request coming at 11:00:01, sorry, 00, and then again one more request coming at same time, right? So what we do, we store them as a bunch, right? So suppose, for example, at this suppose T1 timestamp, right? At this T1 timestamp, we have two requests. So we have log, we have the log entries, and we have this timestamp, and then counter also. So suppose there is one more request, suppose there are three requests coming at this point of time, then we'll update it to 3, right? So we'll be having the value as a 3 in this log. So now, rather than having 3 entries in this log, we will have just one entry with the counter and the timestamp. So similarly, if we have suppose 0005, we get suppose three entries again. So what we do, we again go and save it here. T1 slash, sorry, T2 slash 3, right? So now what happens that similarly, suppose we have a few more entries which we have done, right? Suppose T2 5, T3 5, then we have the time 3, sorry, T1, T4, T4 6, right? So now what we do, now, same thing, right? What we do for last 1 minute, right? For last 1 minute, suppose our the rate of I mean rate limit we have decided as a same like 10 request per minute. Okay, so for last 1 minute, right? So for last 1 minute, we'll see. Okay, so we have served 3 plus 5 8 plus 6 14 requests, right? So we have already served more than the SLA of our 10, right? So we will not serve any more requests, right? So for example, there is one more 1 minute has elapsed. Now these requests are beyond that 1 minute, last 1 minute. So now in last 1 minute we have just these two entries like suppose 11, 5 6 11, right? Still we see that okay, we have served that 11 requests, right? So we will not serve any more requests. Similarly, suppose now you have one more entry here. Suppose you have one more entry. Say suppose T 5 slash 2, right? So here we have this entry. So now you can see that okay, in last 1 minute we have just 8 requests served, right? So now this is within our SLA. So we'll serve. So now here in this algorithm, what is happening that we are basically trying to utilize both things. So from the setting logs, we what we are doing, we are using the log feature. We are storing all requests, but not in a separate, but we are combining them as a timestamp in the counter. And then for last 1 minute, we are trying to see how many requests we have served. And based on that, either we are processing more requests or discarding them. So this algorithm is a improvement over the previous algorithms. And yeah, and that's it for this video. So I think I have covered what are the most popular algorithms we use in rate limiter, and I hope you will find this useful. If any questions you have, kindly put in the comment. I will try to answer them for sure. And thanks for watching. Yeah, thanks a lot.